Hello everyone, this is the problem of the week solution video for last week's problem of the week heart rate. I'll read through this problem description and then we can go through an example solution in Python as usual. A common method for determining your own heart rate is to place your index and third finger on your neck to the side of your windpipe. You then count how many beats you feel in a span of 15 seconds, multiply that number by 4, and that gives you a measure of your heartbeat in beats per minute. This measure gives a good estimate but is not quite accurate. In general, if you measure B beats in P seconds, the BPM is calculated as 60 times B divided by P. For this problem, we assume that all heart rates are constant and do not change. If T is the amount of time in seconds between each beat of your heart, we define your actual beats per minute, A BPM, as 60 divided by T. Our input starts with the integer n, where 1 is less than or equal to n is less than or equal to 1000, indicating the number of cases to follow. Each of the next n lines specify one case consisting of the integer b, where 2 is less than or equal to b is less than or equal to 1000, as well as p, where 0 is less than p is less than 1000, as described above. The value of p is a real number specified to 4 decimal places. Alright, so this is great. If you recall from the formula, we must divide by a certain value, and since that value is p and p cannot be 0, we won't run into any issues with dividing by 0. As for our expected output, we should print on a single line the minimum possible ABPM, the calculated BPM, and the maximum possible ABPM specified by separated by a space. And it also says that we have to give it a precision of at least 10 to the power of negative 4. Okie dokie. So reading through this problem, it seems that all we need to do mathematically is just plug in our numbers into this formula above, which is 60 times b divided by p. The more difficult part is probably interpreting the minimum possible ABPM versus the calculated BPM versus the maximum possible ABPM. We can actually determine what these actually mean by analyzing the sample input. So let's just take the first line of our sample input right here. As you can see, the line says 6, 5.0000 corresponds with our output line 60, 72, and 84. If we were to plug in 6 and 5 into our formula 60b divided by p, then we would see that our calculated BPM is actually 72. The pattern here is that the minimum BPM is just one heartbeat fewer than the calculated BPM, and our maximum BPM is one heartbeat greater than the calculated BPM. Using these variables that are given, we know that all we have to do is basically subtract 1 from the b value to get the minimum ABPM, and add 1 to get the maximum ABPM. Let's visit the example code now. Okay, so the first thing we do here is to get our value of n, which is how many values that we expect to be given. Then an empty list is created for all of our solutions. You might recall the purpose of this from some previous problems. So the reason we make this list is to keep all the solutions from printing out until we've entered all of the inputs, which would make it look nicer. It's totally not necessary for getting it marked right in Caddis, but it doesn't change the program too much to just have it. In lines 4 through 14 is our main loop. Basically, for n times, we run everything inside this block. The first thing we do here is to take the input lines and split it into two segments using the .split function, which basically breaks up the input into a list of strings. In this case, it will be 2. Here we then cast it into a float because we need to be able to work with the numbers and also keep at least 4 decimal places. So we save those to the variables b and p. All the calculations that we're doing is happening in this next block. In lines 10 through 12, we basically plug in b minus 1, b, and b plus 1 into our formula, and to get our 3 numbers. Finally, these numbers are formatted right here in line 13 into a string and appended into our solution list. Because it's Python, you can also pack a lot of stuff into one line. This section in line 14 does the same thing as lines 10 through 13. So either way works. Now that everything's in our list, our last step is just to print everything out from our list of solutions. So a quick for loop and prints out everything in our required entries. That'll be it for the solution code, so let's try our example output. Our first value is n, which is 2. Entry 1 is 6, 5.0000, and entry 2 is 2, 3.1222. Our expected output is 60, 72, 84, and 19.2172, 38.4344, and 57.6517, but we're allowed to be more precise to than 4 decimal places. And as you can see, that is matching up, so our program is working as intended. That'll be it for this problem of the week video. Thank you.